Imagine a creature smaller than a grain of sand, surviving in space, boiling water, and near absolute zero. This is the reality of tardigrades, microscopic animals renowned for their resilience. Found everywhere from mountains to oceans, they are Earth's toughest animals. Join us as we explore their remarkable abilities and the secrets they hold. Tardigrades are a testament to evolution's power, withstanding extreme conditions through unique adaptations. Found worldwide, they thrive in diverse habitats, from backyards to the Arctic. Their resilience makes them valuable for scientific research, potentially aiding space travel and medicine. Could they help us understand life beyond Earth? Their story reminds us of life's incredible adaptability. Tardigrades are multicellular organisms with complex bodies, despite their tiny size. Their segmented bodies and stubby legs give them a bear-like appearance. Their tough cuticle acts as armor, protecting them from extreme conditions. These microscopic bears showcase nature's incredible efficiency. Tardigrades, with their 8 legs and tiny claws, navigate their world with surprising agility. Their slow movements conserve energy, and their strong grip withstands extreme forces. Sensory organs help them perceive their surroundings, while piercing stylets allow them to feed. These adaptations make them perfectly suited for their microscopic lifestyle. Tardigrades inhabit diverse environments, from the Himalayas to ocean depths. They survive extreme conditions, including freezing, intense radiation, and dehydration. Their ability to enter cryptobiosis allows them to pause life during harsh conditions. This resilience earns them the title of Earth's toughest animals. The name tardigrade means slow step, but their nickname, water bear, captures their bear-like appearance. They need water to move, feed, and reproduce, making them essentially aquatic. Their resilience and complexity go beyond their cuddly nickname. Tardigrades challenge our understanding of life's limits. Tardigrades' resilience comes from biological adaptations like cryptobiosis. This state allows them to shut down metabolism during harsh conditions. Their tough cuticle and DNA repair mechanisms protect them from damage. These factors make tardigrades the ultimate survivors. Tardigrades thrive in extreme temperatures, from deserts to Antarctic winters. They produce heat shock proteins and cryoprotectants to survive heat and cold. These adaptations prevent damage and allow them to resume life after freezing. Tardigrades are true extremophiles, thriving where others cannot. Tardigrades thrive under immense pressures, like those in ocean trenches. Their tough cuticle and cell membrane adaptations protect them from compression. They can enter a cryptobiotic state to survive extreme pressure. Tardigrades showcase evolution's power to produce resilient life forms. Radiation, an invisible force deadly to most life forms, is just another Tuesday for the mighty tardigrade. These microscopic marvels withstand radiation levels lethal to humans. Imagine shrugging off X-rays, gamma rays, or space radiation like a mild sunburn. Their remarkable radiation resistance captivates scientists, fueling research into protecting humans from radiation damage. But how do they do it? Tardigrades have evolved a multi-pronged defense against radiation. One key defense is their ability to efficiently repair damaged DNA. Radiation can cause breaks and mutations in DNA. Tardigrades possess robust DNA repair machinery. They also produce protective molecules like antioxidants. These antioxidants neutralize harmful free radicals. Tardigrades survive radiation levels thousands of times higher than lethal to humans. This ability interests scientists for cancer treatment and space exploration. Imagine hitting the pause button on life, entering suspended animation during harsh conditions, and reanimating when it's safe. This is cryptobiosis, a survival strategy of tardigrades. They endure extreme environments, making them ultimate survivors. Tardigrades enter cryptobiosis, shutting down metabolism and appearing lifeless. They can remain in this state for decades, reanimating when conditions improve. Since their discovery, tardigrades have captivated scientists with their resilience and enigmatic biology. These microscopic marvels withstand extreme conditions, challenging our understanding of life's limits. Their study unveils biological adaptations, allowing survival in harsh environments and even space. Early observations revealed their incredible survival skills. Tardigrades' adaptations include cryptobiosis and DNA repair mechanisms. Their study expands knowledge in astrobiology, biotechnology, and medicine. Tardigrades inspire research into organ preservation, radiation protection, and biomaterials. Their journey of discovery continues, revealing further complexity and intrigue. The story of tardigrade discovery begins in the 18th century, a time when the invention of the microscope was opening up a new world of microscopic wonders. It was in 1773 that German pastor and zoologist Johann August Ephraim Goethe first described these tiny creatures, observing their slow, bear-like movements under his microscope. He named them Kleine Wasserbar, meaning little water bear in German, a moniker that has endured to this day and continues to capture the public's imagination. Early observations of tardigrades focused primarily on their morphology, their unique appearance, and their lumbering gait. Scientists were intrigued by their 8 stubby legs, their plump, segmented bodies, and their ability to move through water with surprising agility for their size. However, it was their remarkable ability to withstand desiccation that truly set them apart from other microscopic organisms. In 1776, Italian biologist Lazzaro Spallanzani discovered that tardigrades could be dried out completely, appearing lifeless, only to reanimate when rehydrated. This incredible ability, which he termed resurrection, astonished the scientific community and sparked a wave of research into the secrets of tardigrade survival. Spallanzani's observations laid the groundwork for our understanding of cryptobiosis, the state of suspended animation that allows tardigrades to endure extreme conditions. His pioneering work marked the beginning of a long and fascinating journey into the world of tardigrades, revealing their incredible resilience and challenging our understanding of the limits of life itself. Tardigrades, the ultimate survivors, were launched into space in 2007 by the European Space Agency. Exposed to space's harsh conditions, they survived the vacuum, extreme temperatures, and solar radiation. This experiment, known as TARDIS, tested their resilience and potential for life beyond Earth. Upon return, many tardigrades revived, resumed activities, and produced offspring. This marked the first time a multicellular animal survived space, solidifying their place in space exploration history. The remarkable resilience of tardigrades has long captivated scientists, prompting them to delve into their genetic makeup in search of the molecular secrets behind their extraordinary survival skills. The sequencing of the tardigrade genome, a landmark achievement in tardigrade research, has provided valuable insights into the genetic underpinnings of their resilience, revealing a treasure trove of genes and molecular pathways that contribute to their ability to withstand extreme conditions. One of the most striking findings from tardigrade genome sequencing is the presence of a high number of genes involved in DNA repair. These genes, many of which are present in multiple copies, provide tardigrades with a robust toolkit for fixing DNA damage caused by radiation, dehydration, and other environmental stresses. This enhanced DNA repair machinery is thought to be a key factor in their ability to withstand high doses of radiation and other DNA-damaging agents. Furthermore, tardigrade genomes harbor a unique set of genes that code for proteins known as tardigrade-specific intrinsically disordered proteins, or TDPs. These TDPs, which lack a fixed three-dimensional structure, are thought to play a critical role in protecting tardigrade cells during dehydration. They are believed to form a protective gel-like matrix within cells, preventing proteins and other cellular components from aggregating and becoming damaged as water is removed. This unique adaptation is thought to be a key factor in their ability to survive extreme desiccation and reanimate upon rehydration. The incredible resilience of tardigrades is not solely due to a single superpower, but rather a result of a cleverly assembled toolkit of adaptations, a testament to the power of evolution to equip organisms for survival in even the harshest environments. Their ability to withstand extreme temperatures, pressures, radiation, and dehydration is a result of a synergistic interplay of unique biological mechanisms, each contributing to their remarkable survival skills. Their tough outer cuticle, a multi-layered exoskeleton that acts like a microscopic suit of armor, provides protection from physical damage, dehydration, and even some forms of radiation. This resilient cuticle, composed of chitin, proteins, and lipids, acts as a barrier against the external environment, helping to maintain the integrity of their internal organs and systems. Furthermore, tardigrades possess an exceptional ability to regulate their internal environment, maintaining a stable internal state despite fluctuations in their surroundings. They can tolerate extreme changes in salinity, pH, and even the presence of toxic chemicals, thanks to specialized cells and physiological mechanisms that help to detoxify and excrete harmful substances. This remarkable ability to maintain homeostasis even in the face of environmental challenges is a testament to their finely tuned physiological adaptations. Tardigrades, with their incredible resilience and enigmatic biology, have emerged as more than just microscopic curiosities. They have become valuable model organisms, inspiring research in a wide range of fields, from astrobiology to biotechnology and medicine. Their ability to survive the vacuum of space has fueled speculation about the potential for life beyond Earth, while their remarkable resilience has sparked interest in developing new methods for preserving organs and tissues, protecting humans from radiation damage, and even creating novel biomaterials. In the field of astrobiology, the study of life beyond Earth, tardigrades have become prime candidates for investigating the limits of life in the universe. Their ability to survive the harsh conditions of space, including the vacuum, extreme temperatures, and radiation, suggests that they may be capable of surviving on other planets or moons within our solar system or even beyond. Furthermore, their remarkable DNA repair mechanisms and their ability to withstand extreme desiccation have piqued the interest of researchers seeking to develop new methods for preserving organs and tissues for transplantation. The ability to dehydrate and rehydrate organs without causing damage could revolutionize organ transplantation, potentially saving countless lives. Their study also holds promise for developing new strategies for protecting humans from radiation damage, particularly during long-duration space travel. Understanding how tardigrades withstand high doses of radiation could lead to new protective measures for astronauts, as well as for patients undergoing radiation therapy for cancer. Tardigrades, the microscopic marvels, have conquered Earth's most extreme environments and set their sights on space. Their resilience in space challenges our assumptions about life's limits and offers insights into extraterrestrial possibilities. Scientists study their radiation resistance to develop new protective measures for astronauts. Tardigrades guide us in the search for extraterrestrial life, expanding our horizons. The incredible resilience of tardigrades has captivated not only biologists, but also engineers and biotechnologists who see in these microscopic marvels a treasure trove of potential applications for human advancement. Their unique adaptations, honed over millions of years of evolution, offer tantalizing possibilities for developing new technologies in fields ranging from agriculture to medicine and even materials science. One area of particular interest is the application of tardigrade adaptations to improve crop resilience. Imagine crops that can withstand droughts, floods, and extreme temperatures, thriving in environments that would decimate conventional crops. By understanding the genetic and molecular mechanisms underlying tardigrade desiccation tolerance, scientists hope to develop crops that can survive prolonged periods of drought, reducing water consumption in agriculture and enhancing food security in arid regions. Their ability to withstand extreme temperatures also holds promise for developing crops that can tolerate heat waves and cold snaps, expanding the geographical range of agriculture and mitigating the impacts of climate change on food production. Beyond agriculture, tardigrade adaptations are being explored for their potential in preserving biological materials, such as vaccines and pharmaceuticals, at room temperature, eliminating the need for costly and often unreliable cold chain storage and distribution systems. Section 3. Medical Marvels, from Organ Preservation to Radiation Protection. The remarkable resilience of tardigrades has not escaped the attention of medical researchers, who see in these microscopic marvels a potential goldmine for developing new therapies and treatments for a wide range of human ailments. Their ability to withstand extreme conditions, particularly their resistance to radiation and dehydration, has sparked interest in their potential applications in organ preservation, radiation protection, and even cancer therapy. One of the most promising areas of research is the application of tardigrade adaptations to improve organ preservation for transplantation. The current gold standard for organ preservation involves storing organs at low temperatures, a process that, while effective in the short term, can lead to cellular damage and reduce organ viability over time. Tardigrades, with their ability to enter a state of suspended animation known as cryptobiosis, offer a tantalizing alternative. By understanding the molecular mechanisms that allow tardigrades to dehydrate and rehydrate without damage, scientists hope to develop new methods for preserving organs at room temperature, potentially extending their shelf life and increasing the availability of organs for transplantation. Their radiation resistance also holds promise for protecting healthy tissues from the damaging effects of radiation therapy, a common treatment for cancer. By unraveling the secrets of tardigrade radiation resistance, scientists hope to develop new radioprotective agents that can selectively protect healthy cells from radiation damage, reducing the side effects of radiation therapy and improving patient outcomes. Section 4. The Ethical Frontier: Tardigrades and the Responsibility of Scientific Exploration. Tardigrades' resilience has propelled them to the forefront of research, raising ethical considerations. We must proceed with caution, balancing innovation with respect for the natural world. Unintended consequences of applying tardigrade adaptations to other organisms must be considered. Equitable access to tardigrade-inspired technologies is essential for global benefit. Section 1. Tardigrades, a testament to life's tenacity. Tardigrades, those microscopic marvels we've journeyed with, embody resilience. Smaller than a grain of sand, they conquer boiling water, freezing cold, intense pressure, and even the vacuum of space. Their existence challenges our perception of life's limits. Their resilience isn't mere happenstance, it's the result of millions of years of evolution. Their adaptations, honed over eons, have crafted a survival toolkit unlike any other. Cryptobiosis, their secret weapon, allows them to hit pause on life, enduring conditions that would obliterate most other creatures. Their journey has taken them from the depths of the ocean to the heights of the Himalayas, from the lushness of moss to the desolation of Antarctica. Their ability to thrive in such diverse and extreme environments showcases the incredible adaptability of life itself. Their study has shattered our preconceived notions of what life can endure. They've become ambassadors of resilience, reminding us that life finds a way, even in the most unexpected places. Their story is a testament to the tenacity of life, a reminder that size is no barrier to being a true survivor. They've shown us that even the smallest creatures can harbor the most extraordinary adaptations, pushing the boundaries of what we thought possible for biological organisms. Their existence serves as a source of inspiration, a beacon of hope in a world often characterized by fragility and impermanence. Unlocking nature's secrets. Tardigrades, with their remarkable resilience, have captured scientists' imagination. Their study promises to revolutionize our understanding of life and technology. Unlocking nature's secrets, we explore the potential of these microscopic marvels. Their ability to survive space fuels the search for extraterrestrial life. Their resilience inspires new methods for preserving organs and tissues, protecting humans from radiation damage and developing novel biomaterials. Their study holds the key to unlocking biological knowledge. The future of tardigrade research is brimming with possibilities. Unraveling their secrets opens doors to new discoveries and technologies. Tardigrades, smaller than a grain of sand, are heroes in our quest to comprehend the universe. Their story is a testament to curiosity, discovery, and scientific exploration.